Thank you for stopping by our poster at ORS 2023. My name is Soroush Irandoust and I am a postdoc at the University of Wisconsin-Madison. I am excited to run through the poster in this video. Condylar stress fracture of the fetlock is a common fatal injury in thoroughbred racehorses. The distal end of the cannon bone experiences large cyclic loads during galloping, which leads to profound functional adaptation and thickening of the subchondral plate. In some horses with subchondral bone fatigue injury in the parasagittal grooves, microdamage accumulates faster than it is repaired through remodeling, seen as focal osteolysis with standing computed tomography imaging. Articular stress fracture occurs because of intolerable subchondral bone injury. We hypothesized that thoroughbreds with subchondral bone fatigue injury experience higher levels of maximum strain in a site-specific manner, and we wanted to find the influence of subchondral bone injury on surface strains during cyclic loading. We dissected cannon bones, removed the soft tissue and the articular cartilage, potted them and made speckle patterns with an airbrush for optical measurement of surface displacement using an stereo DIC setup. In the first test, we applied 25 loading cycles with peak load of 5 kilonewtons at 0.1 Hz to one of the condyles. In the second test, we loaded the same condyle to failure at 0.2 millimeters per second. We tested 3 bones with different pathologies. One control with no visible lesion, one with biaxial focal osteolysis lesions in the parasagittal grooves, and one with palmar osteochondral disease. The region of interest shown in blue was selected for DIC analysis. Maximum principal strain was calculated at the peak load in the last loading cycle. All specimens showed strain concentration in the parasagittal grooves. The control specimen showed smaller strain in the parasagittal grooves compared to the other specimens. All specimens fractured at the potting interface due to stress concentration. However, the specimen with biaxial focal osteolysis lesion exposed proximal propagation of a new crack from the pre-existing subchondral osteolysis lesion. In summary, our results show strain concentration at the parasagittal groove, even in specimens with no visible injury. Also, elevated levels of strain in specimens with spontaneous subchondral bone injury agrees with our hypothesis. Lastly, the fracture pattern can be affected by pre-existing subchondral bone injury. I want to acknowledge my mentors at UW-Madison, Professor Peter Muir at the School of Veterinary Medicine, and Professor Corinne Henak at Mechanical Engineering Department. Also others who helped with this project, Elijah McCoy, Professor Joshua Roth, who helped with running the experiments, Professor Chris Whitton in Australia, and lastly, Grayson Jockey Club Equine Research Foundation for funding this work. Thank you for listening.